Hello everyone, welcome to my first devlog. In this short video, I'm going to be explaining how I made Tetris, a Py-themed Tetris game, and all the wonderful coding behind the scenes. To start, I'm going to clarify some of the terms I'll be using throughout this video. The basic idea behind Tetris is that it's classic Tetris, except instead of just having tetrominoes, which are shapes with 4 cells, the game will have much higher order polyominoes, which are shapes with cells ranging from 0 to 9. Monominoes have 1 cell, duominoes have 2 cells, triominoes have 3, tetrominoes have 4, pentominoes have 5, hexominoes have 6, and so on and so forth. The order of the pieces in the queue would be in the order of the digits of pi, so the first piece would be a triomino, followed by a monomino, then a tetromino, and so on. I had a big text file containing all the digits of pi in one long string. The first step would be generating the polyominoes. I drew out the different shapes on my iPad and looked for different ways that they could be created in the most efficient manner possible. Eventually, I landed on this method which I like to call pseudo DFS. It boils down to this: take a starting piece, and on each cell, try to add a new cell in all 4 directions. Then do the same for the next cell and the next, until you have all possible new cells that can be added to the original one. I headed into an online code editor and whipped up this function which takes an existing piece, in this case the L tetromino, and spits out all possible cells that can be added in each position. Then I created a function called assign, which outputs all the new configurations of higher order polyominoes that can be formed from lower order polyominoes. I had to use what's called a set to ensure there would be no duplicates. Then I implemented logic to ensure that there would be no holes within the piece as well. The next important piece of the puzzle was the rotations. Tetris' rotation system is very complex and handcrafted, but unfortunately, when there's over 2,000 non-ominoes alone, I just didn't have the time to create the rotations for each one. So I had to create my own centralized rotation system that would work with any polyomino. It simply aligns the piece to the top left corner, or 0, 0, then narrows the bounding box so it can be as centered as possible, and finally rotates the whole grid 90 degrees each time. As I mentioned earlier, there are over 2,000 non-ominoes and over 3,000 polyominoes altogether. However, the code isn't only generating 3,000, it generates many more thousands before narrowing them down and only keeping the valid pieces. Therefore, every time my code ran, it took over a minute and a half just to generate the sheer monstrosity of a list of pieces. This is obviously not feasible in a game, as if a game took that long to run, the user would probably quit before ever reaching the title screen. So it was time to learn something new: JSON files. A JSON file is kind of like a text file that can essentially store structured data like lists. I would have my code run once and generate all the pieces, then write them to a JSON file, which will stay saved even after exiting the code. Reading from this file only takes Python a few moments, rather than the minute and a half it takes to generate from scratch each time. One final difficult part of this project was a neat little feature of modern Tetris called the super rotation system, which allows us to do funky stuff like this. How it works is with something called a kick table. When a piece is rotated, it goes through 5 tests, or kicks. The first is the basic rotation, and after that it will try to offset itself by 1 or 2 cells until it finds somewhere it fits. I tested a few arbitrary values and landed on plus or minus 4 in each direction. This seemed to work alright enough and made the game ever so slightly easier. I added a few more features, got 2 banger soundtracks from 2 YouTubers called Music8Bits and Lofi Lia, link in the description, ironed out some bugs, created a bit of artwork, and the project was done. There's a lot that I didn't cover in this video about the process, and the game is still not quite finished, but I wanted to keep it short and focus primarily on working on the polyominoes and modifying basic Tetris. If you enjoyed this devlog, please let me know in the comments below. Maybe I'll make another one and go more in depth, or maybe cover some of my other game dev projects. Thanks for watching.